Welcome back, everyone. Today I want to give a brief summary of the three things I always keep my eyes out for in the field when I'm looking for big gold nuggets, and why I think all three are often tied together and related to larger gold nugget formation itself. The first is large pyrite crystals. The second is larger quartz crystals, or really, as I'll explain it later in the video, any type of larger crystalline growth of any type of mineral. And then the third is Vugs or boxworks within quartz. This one, is that focusing? Focus! You can see a nice example. Well, I guess it's not showing up on the camera. In that little honeycomb structure in there, there's actually a bunch of little teeny pieces of gold. But anyways, from Nevada to Colorado to Arizona, I've observed the same things time and time again. And for instance, this is a specimen from Nevada. These are pyrite. These are hematite after pyrite pseudomorphs in shale. Sorry. This is from Colorado. This came out. These are also hematite after pyrite pseudomorphs that came out of a very small, about 1 centimeter wide vein in schist. And then this came from Arizona. This is pyrite in rhyolite, is what that is. And I'm not a geochemist, so this theory is based only on my field observations and correlations. But my theory is that the same processes that allow for large crystalline growth in pyrite and quartz also allow for large gold nugget growth. Because to grow, large crystals require space, which the Vugs provide. And they also require nucleation sites, which I believe nugget-sized gold requires as well. Especially in hydrothermal deposition type settings. A surface can provide a nucleation site for gold, and a honeycombed or boxwork structure, which you commonly see in quartz ore, provides a very high surface to space ratio, which seems to provide favorable areas for gold to precipitate out of a solution. In this large slug I've smelted, you can see the clear cubic crystal formation, and it appears that gold can even use its own surface as nucleation sites. What this might mean is that big gold leads to even bigger gold, as crystals formed in multiple nucleation sites can combine into one larger gold crystal, or nugget as we call them. So consider this crumpled ball of paper, for instance. Gold could begin precipitating out on many adjacent nucleation sites, and then slowly begin combining into a larger nugget. Yet, if it was uncrumpled, these same nucleation sites that were once millimeters apart could now be separated by inches or feet or more. And what you're getting in these honeycombed or boxwork type structures or within Vugs is you're getting this crumpled kind of paper geometry, similar to like how the human brain is folded in on itself. So you have a large amount of surface area in a tiny area, and that's why gold tends to form in these Vugs, boxworks, or honeycomb type structures, I think at least. When I find pockets of gold, they're almost always accompanied by well-defined quartz crystals and contained within like a golf ball or a fist-sized Vug. These pockets can also contain some pretty spectacular gold crystals as well. When you're prospecting new areas and looking for big nuggets, make sure to keep an eye out for crystals. The most common are pyrite and quartz, but I've also found other crystals like vanadinite, wolfenite, calcite, fluorite, barite, things like this associated with gold in the past. So always keep your eyes peeled. Sorry about that, my heater kicked on. I wanted to show an example of gold being associated directly with pyrite, even in its free milling state. These three nuggets all display what would commonly be, I guess, mistaken as a trigonal crystal habit, when in fact what it is 10 or 15 different pyrite molds within this particular nugget. Same with this flaky one. It's actually... is that focusing? It's actually a flat flake, but even within the flake you can see little trigonal molds, which are the remnants of the corner of a pyrite cube. This one is, let's get that focus there. That one's a pretty stark example. And when you look closer, I don't think it's going to show up on the camera. There's actually some patterning on here that looks crystalline, but it's actually molds. So anyways, big gold isn't always associated with crystals, but like black sands, when you find them, it's often worth investigating closer. And in a lot of cases, it's led me to some pretty nice finds. So thanks for watching, everyone, and don't be afraid to leave some feedback if you feel I said something incorrect here, or if you have another geologic indicator that you like to look for in the field yourself. Alright, see you on the next video. Bye.